So this lesson continues looking at the ideas of the 5-number summary from last lesson with a focus on these box and whisker plots, which we can see one right on the screen here. And in general, a box and whisker plot is a way of just visualizing the 5-number summary, in which we have always 5 points. Wherever it starts, whatever point that is the minimum. The first quartile is always the beginning of the shaded box. The median is always a line somewhere in the shaded box, not necessarily the middle. The third quartile is always the end of the shaded box, and then the maximum is the last point. All right, so if we look at an example of a box and whisker plot, we have one here. It says a student records the nearest tenth their hours of sleep for 60 nights. And we see the box and whisker plot. I want the 5-number summary. As well, would either the maximum or minimum be considered outliers? Okay, before I talk about the outlier part, let's look here. This represents the data for the student's sleep over 60 nights, how many hours of sleep they got. And so if we look right here, this lowest point right here, 2 hours is the minimum. So that, I'll just write that down here. The minimum is 2 hours. And I'll work my way up. This, where the shaded box begins, that's my first quartile. That's 5 hours. And so Q1 is 5 hours. And then the median is always the line somewhere in this shaded box. In this case, I can see it looks like it's roughly halfway between 6 and 7. So I'll say 6.5. So the median, or Q2, 6.5 hours. And then the third quartile looks like halfway between 7 and 8, so 7.5 hours. And finally, the maximum is the end of our box and whisker plot right here, which was 11 hours. It's a lot of sleep in one day, but I guess it makes up for the 2 hours they got another day. All right, that's our 5-number summary. Now, the other thing I ask is, would either the maximum or the minimum, so either the 2 hours or the 11 hours, would they be considered outliers? Now, well, outliers came up in a previous lesson, and part of this we have a more definitive description of what an outlier is, and we can see right here. Any value in the data set that is more than 1.5 times the IQR, that interquartile range, below Q1 or more than Q3 is considered an outlier. All right, so what do I mean by that? Well, let's look here. Let's first find the IQR, the interquartile range, which is just the difference between these values. And so it's the IQR is 2.5. So if something is an outlier, we want to take that and multiply by 1.5. And if we multiply by 1.5, we get 3.75. So if there are any outliers in this data set, there should be a value that is either at least 3.75 up from Q3 or let down from Q1. So if there are values in this data set within, that have this characteristic, they are considered outliers. Well, let's look at this in more detail. Remember, this third quartile was at 7.5. If I add 3.75, I get to more than 11. And so 11 is not considered an outlier. It's not more than 3.75 or 3.75 or greater from Q3. So the maximum is not an outlier. Same thing for the minimum. If I subtract 3.75 from 5, I get 1.25, not 2, which means 2, that minimum is not considered an outlier. It's not far enough from Q1 or Q3 to be considered an outlier. And so I now know that because of this, the max and the min, neither the max nor the min are outliers. They're close. It's a lot of sleep or very little sleep, but not outliers. All right. Last question on this box and whisker plot. Estimate the number of nights the student slept between 5 and 7.5 hours in a night. Well, if I look at this, here's 5, here's 7.5 hours, which is, what do you know, everything that's shaded in this box. So what does this box represent? This represents everything from the 25th percentile to the 75th percentile. That's what the first quartile and the third quartile are. And the median is the 50th percentile, which means everything inside this shaded box is exactly half of our data. It's 50% of our data. And the question is 50% of what? 50% of our data being 60 nights. And so now I know that half of 60 is how many times this person slept between 5 and 7.5 hours, which is 30 nights. And so I can say 50% of 60 nights, which is 30 nights. All right, so before I go on, just keep in mind, every time we see a box and whisker plot, this shaded region is always from the first to the third quartile, which means everything inside here is always exactly half our data. As well, half our data is this region here and this region here added up. All right, the last question is coming back to this idea of a cumulative frequency graph. And here I have a cumulative frequency graph comparing the frequency of these ore samples. So as it says here, a mining company is trying to decide whether a particular region would be a good location for the next copper mine. They perform a feasibility study by collecting 40 samples from around the region and calculating the percentage of each sample that is made of copper ore. The cumulative frequency curve below, or actually beside, shows the data they collected. All right, and we want to find estimate the percentage of the samples that has more than 60% copper ore. All right, so if we look here, if I just pick a point, maybe I'll pick this point right here, okay? That is, if I look at the scale here, that looks like 42%. Nope, 44%. So we'll say that point there represents that 44% of the samples, that 20 of the samples have at most 44% copper. And if I look at this point right here, this represents that 10 of the samples have at most, that's 28% copper. So that's how we read this. Remember, cumulative means we add everything before. So as we work our way up, it includes everything before. This here is how many samples have at most 100%. At least, at most. I feel like I've been saying those the wrong way around. Anyways, let's answer the question. Estimate the percentage of samples that has more than 60% copper ore. So first, let's find 60% copper ore. So first, 60%, that's right there. That's roughly right there. And what is that? That's roughly 25. It's hard to tell if it's exactly on it. So 25 out of 40. So we'll say 25 out of 40 samples have at most 60%, right? This is a cumulative. This is 60% or less. So have less than or equal to 60% copper. Which means if 25 out of 40 have up to 60%, all the rest must have more than 60%. All the rest being the other 15. So that means I have 15 out of 40 samples have more than 60% copper ore. All of these right here, all of these samples here have more than 60% copper ore. So what percent of the total? Well, it's 15 out of 40, which is 37.5%. So 37.5% of all the samples have more than 60% copper ore.